Welcome to Study Loop.
So in this problem, first we will find out the number of moles of HCl which is treated by the limestone rock, and then we will find out the number of moles of sodium hydroxide from its volume and molarity, um, which is reacting with the excess HCl from the treatment of limestone rock, and from there we will be able to find out the number of moles of the excess acid using the balanced equation of the reaction of sodium hydroxide and HCl. And from that number of moles of excess acid and from the number of moles of the total HCl added, we can find out the number of moles of the HCl which is used in the treatment of the limestone. And from there, we'll be able to find out the number of moles of the limestone or calcium carbonate which is being treated by that number of mole of HCl, and from that number of mole of the limestone we'll be able to find out the mass of the calcium carbonate in the limestone, and from there we'll be able to find out the percentage of the calcium carbonate in the limestone sample. So first we'll find out the number of moles of HCl which is added to the limestone, and that will be simply the product of the molarity and the volume of the HCl added. So it will be 1.035 molar or mole per liter, which is the molarity of the HCl times the volume, which is 30 milliliter or 30 times 10 to the power minus 3 liter, and this will give us a value of 0.0310 mole. Now we will find out the number of moles of the sodium hydroxide which is reacting with the excess HCl. So the number of moles of sodium hydroxide will be again the molarity times the volume of the sodium hydroxide, and it will be 1.010 molar or mole per liter times the volume of the sodium hydroxide, which is 11.56 milliliter, or 11.56 times 10 to the power minus 3 liter. So this is the volume of the sodium hydroxide which is required for the neutralization of the excess HCl. So just multiplying this volume by the molarity of the sodium hydroxide, we can find out the number of moles of sodium hydroxide which was used, and it will be 0.0117 mole. Now we'll write down the balanced equation for the reaction between HCl and sodium hydroxide. So it is simple monoprotic acid. That means it will be a 1:1 reaction. That means 1 mole HCl will react with 1 mole sodium hydroxide. That means this much mole sodium hydroxide will react with the same number of mole of HCl. That means number of mole of HCl excess will be same as the number of mole of sodium hydroxide, which is 0.0117 mole. Now, subtracting this number of mole from the original number of mole of HCl, we can find out the number of mole of HCl which is reacted with the calcium carbonate. So, number of moles of HCl reacted will be equal to the total number of mole of HCl 0.0310 minus the number of mole of HCl excess 0.0117 mole, and it will give us a value of 0.0193 mole. So this is the number of mole of HCl which is reacted with the calcium carbonate in limestone. Now we will write down the balanced equation between the calcium carbonate and HCl. So it will be calcium carbonate in solid form will react with 2HCl. We are directly writing the balanced equation will give us calcium chloride in aqueous form plus hydrogen carbonate. Now from here you can see that 1 mole of calcium carbonate reacts with 2 mole of HCl. So we can write 2 mole HCl is identical to 1 mole calcium carbonate. That means 0.0193 mole HCl will react with or will be identical to 1 over 2 times 0.0193 mole of calcium carbonate, which will give us a value of 0.0096 mole calcium carbonate. So this is the number of mole of calcium carbonate in limestone which react with HCl. Now from here we can find out the number of mass of calcium carbonate which is reacting or which is present in the limestone. So the mass of calcium carbonate will be equal to the number of moles which we just have calculated, 0.0096 mole times the molar mass of calcium carbonate, which if we count we will find a value of 100.1 gram per mole. And from here we can find out the value of the mass of calcium carbonate, which will be 0.9650 gram of calcium carbonate. So this is the mass of calcium carbonate present in the limestones. That means the percentage of calcium carbonate in the limestone sample will be the mass of calcium carbonate over the mass of the sample, which is 1.248 gram times 100%, and it will give us a value of 77.32%. So this is the percentage of the calcium carbonate uh, in the rock sample.